Okay, so this is chapter 19.5 notes, which is vertex of a parabola. And we are going to go over applications and modeling. So the concepts we're going to go through is how to write a quadratic function in vertex form. That's what this formula is. And we talked about this formula last time in 19.4. We're going to look at that vertex formula, and then we're going to determine the vertex and intercepts of a quadratic function, and then look at some applications that we would use this vertex formula for. So concept 1, writing a quadratic function in the vertex form. We are going to be using that concept of completing the square. Okay, so that concept we learned a couple notes ago of completing the square is coming back again. And in the first example, it says given the function f of x is equal to x squared plus 8x plus 13, answer the following questions. Okay, so for the first question, it says write the function in vertex form. Okay, in order to write it in vertex form, we'd use completing the square. So first I'm going to write my function. So f of x is equal to x squared plus 8x plus 13. Okay. Then I'm going to take out any GCFs that I see in the first two terms. So if I'm looking at the first two terms, are there any numerical GCFs that I can take out? Numerical? No. It's because I have a 1 and an 8, meaning the most I can take out is just a 1. So I'm just going to emphasize that step by writing it. So f of x is equal to 1 parentheses x squared plus 8x close parentheses plus 13. I'm emphasizing that the only number I could take out of those two terms was a 1. Okay. From here, I need to find my n value. So f of x is equal to 1 parentheses x squared plus 8x plus n, and then plus 13. Let me see. I forgot this part in the beginning. So remember, if I add n to one side, I need to add it to the other side. So f of x plus n. Okay. The formula for that n, we just went over that, is that 1/2 b squared. Okay. So n is equal to 1/2, what's our b value? 8 squared. So half of 8 is 4, and 4 squared is 16. So wherever I see that n, I'm going to be placing a 16. So this is f of x plus 16 is equal to 1 parentheses x squared plus 8x plus 16 plus 13. Now that I did my completing the square part, that means I could write this parenthesis here as a perfect square. So remember, the number that I write here is that number that was inside the parentheses for our n. So I have f of x plus 16 is equal to 1 x plus 4 squared plus 13. And remember, I got that 4 from my formula here. That's where the 4 came from. And then last step is I just want my f of x by itself. So that 16 that I added on that side is going to have to do what? If I want f of x by itself. subtract 16. And that's just going to be subtracted to that c value at the end. So I have f of x is equal to 1 x plus 4 squared minus 3. This is now in vertex form. Okay, so we went from quadratic form to vertex form. Okay. Who remembers why it's called vertex form? What can we find from this equation?
Find the point of the vertex.
Good, we can find the point of the vertex. So this tells us that this is our h value and this is our k value. Because the vertex, and that's the next question here, is h comma k. But what do we know about h? H always has to have the opposite, what? Opposite sign. So in this case, our point is going to be what? -4, comma, because that's our h value, -3. That is our vertex. So whatever that k value, that just comes down. The h value is the only one that changes the sign. So notice in our problem it was a +4, but for our vertex we write a -4. The reason for that is if we go back up to our original formula, notice how we have a negative in our formula. Right here, this negative. So that's why we always just do the opposite sign of whatever the number is, because of that formula. Okay. Okay, then we need to find the axis of symmetry. Who remembers how we find the axis of symmetry? We use the vertex to find it. So
X equals H.
good. For the axis of symmetry, it's x equals h. And what's our h value? Good, so it's x equals -4. And then lastly, we use our vertex again to find our minimum or maximum value. So if our axis of symmetry was the x equals h, what would be our minimum or maximum value come from? So we already used the h. What's the only one we didn't use? K. So that means our minimum value is going to be what? -3. Perfect. Okay. So using all this information, you are able to graph. So just keep that in mind if you're asked to graph on the test. You are able to graph using all this information here. This question's not asking us to graph, so we're going to go ahead and look at number 2. Okay, number 2, it's asking us the same thing. So it's giving us a quadratic formula, or sorry, a quadratic equation that is in standard form, and we need to turn it into vertex form. Okay, so I'm going to write my equation first. And remember, my first step is to see if I can take a numerical GCF from the first 2 terms. Am I able to do that? Good, -2. So I have f of x is equal to -2 x squared minus 6x minus 16. Let me write this off to the side. Steps. Take numerical GCF out of first two terms. Okay. What's my next step? Complete the square, so my n value. So I'm going to first rewrite this equation with n. So I have f of x, okay, minus 2n. Why am I writing minus 2n and not just minus n? Yeah, because I took out a numerical GCF of -2. So that means whenever I write my n, so you'll see here, let me write my n. When I write my n on the inside of these parentheses, if I distribute that 2, technically I'm adding a -2n to the right side. So I have to make sure I add the exact same thing to the left side, which is also a -2n. Okay, last question we didn't have to do that because our GCF was 1. We don't need to write 1n. Okay, so write your n's. And then make sure not to forget that GCF. Okay, now we're completing the square. So completing the square, we use the formula n is equal to what? Good, 1/2 b squared. So 1/2, and what is our b value? -6 squared. So we have -3 squared, which is 9. Okay. So that means my n values are 9. So f of x minus 2 times 9 is equal to -2x squared minus 6x plus 9 minus 16. Anywhere I saw an n, I put a 9. Okay. Now I can reduce this as a perfect square. What number is going to go there when I rewrite this as a perfect square? Remember, it comes from my n equation. It's going to be that -3. So it's whatever the number is before I square it. Okay? So that means I am going to write this as f of x minus 18 is equal to -2 times x minus 3 squared minus 16. Okay, so I completed the square. And then my last step is to do what? Add the 18. So get f of x by itself. So I'm going to add the 18, and I'm only adding it to that c value at the end. So I have f of x is equal to -2 x minus 3 squared plus 2. So I changed my standard quadratic equation into vertex form. And see, even though this is not being tested directly on test 5, there are some concepts that we already went over. So this is a good review of some of those concepts. Okay. So then for part B, finding the vertex, we know vertex is h comma k, so what is going to be our vertex? 3 comma 2. And why is it positive 3 and not negative 3?
You always take opposite sign.
Good. Opposite sign. Okay. What is the axis of symmetry? What's the formula? X equals H. So in this case, it's X equals 3. Okay, it says find the maximum. Remember, the maximum or the minimum is both what value of the vertex? K. So maximum equals K, which means maximum equals 2. Okay. Now we have a new question on here. We have find the x and y intercepts. New question as in different from the first example. We already learned how to find x and y intercepts. How do we find the x intercepts? Good. Plug in 0 for y. That's the x-intercepts. How do we find the y-intercepts? Plug in 0 for x. Think the opposite. Okay. So the first part we're going to do is we are going to do the x-intercepts. When we're finding the x and y intercepts, it's easiest just to go back to our equation in standard form. Okay, so our equation in standard form was that negative 2x squared. So f of x equals negative 2x squared plus 12x minus 16. Plus 12x minus 16. So if we're finding the x-intercepts, we need to plug in 0 for y. But we don't see y here, but we remember that y is the same as what? F of x. So this is going to be 0 is equal to negative 2x squared plus 12x minus 16. This shows us that we have a quadratic equation equal to 0, so we're going to have to try to factor. Before we factor, can we take out a GCF? Before we factor, can we take out a GCF? Good, a negative 2. So I'm going to take out a negative 2, and I'm left with x squared minus 6x plus 8. Okay, and I'm writing in 2 different colors. Let's do red is for the x-intercepts, blue for the y-intercepts. Okay. From here, I factor using the AC method. So A times C is 8, and our B value is negative 6. So do we have 2 numbers that multiply to 8 but add to negative 6? Good. Negative 2 times negative 4. So that means I have x squared minus 2x minus 4x plus 8 equals 0. Then I do my factor by grouping. What can I take out of the first one? An x. So I have x and then x minus 2. And what can I take out of the second one so they match? Good, negative 4, so I'm left with x minus 2 equals 0. So that means my factors, I'm going over here, are x minus 2 and x minus 4 equals 0. But I can't forget about the GCF, and what was my GCF? Negative 2, I put that in the front. So now I set each term equal to 0. So negative 2 equals 0. That doesn't make sense. That's false. I ignore it. X minus 2 equals 0 means I have x is equal to 2. And x minus 4 equals 0 means I have x is equal to 4. So that means what are my 2 points for my x-intercept? Good. 2, 0 and 4, 0. These are my x-intercepts. Okay. And then now I need to find my y-intercepts. And what do I do for my y-intercepts? Make x 0. So I have f of 0 is equal to negative 2 times 0 squared plus 12 times 0 minus 16. What's going to happen to those first 2 terms? Cancel, because they're getting multiplied by 0. So that means I have f of 0 is equal to negative 16. And how do I write that as a point? Perfect. And this is my y-intercept. Okay, so far I turned my standard quadratic equation into a vertex equation. I found my vertex, I found my axis of symmetry, I found my maximum value, I found my x and y intercepts, and now I'm going to use all that information that I found to graph my function. So in order to graph my function, these are the key points you need to graph. You need to graph your vertex. You got to graph your x and y intercepts. And once we have all those, we're able to draw our function. So first, graphing my vertex. I know my vertex is at 3, 2. So 3, 2, there's my vertex. Then I'm going to graph my x-intercepts. So I have 4, 0 and 2, 0. That's 2 and 4. And then I have my y-intercept, which is negative 16. I don't got 16 spots on here, so I'm just going to count by 2s. 2, 4, 6, 8, 10, 12, 16. So there's my negative 16. Now it looks like that this function is going to be pointing up or pointing down? Down. And I know this because at the very beginning, my a value was what? Negative. And since my a value is negative, I know my graph is going to be upside down. Okay. I also know that it's going to be symmetric on both sides, and I know that because of the axis of symmetry. And my axis of symmetry goes straight down the middle at x equals 3 through my vertex. So if I'm going to graph this, I'm going to make sure I make this as symmetric as possible once I connect these points and then draw my arrows at the bottom. So you make sure you plot your vertex, then your intercepts, then your axis of symmetry. That way we get a very accurate graph. Like if you were to use a graphing calculator, it would look almost exactly like this because we got all points necessary to graph this function. Okay, any questions on concept 1? So again, that was taking standard form into vertex form. And the only reason we do that is because it's easiest to find the vertex that way. And you would want to find the vertex, especially if you're going to have to graph. Okay. Well, another way to find the vertex is using the vertex formula. So let's say you don't want to change the equation from standard form to vertex form, and you would prefer to use an equation. This is the equation you would use. Okay, so it shows you two different ways to write it. I like looking at this one right here. So what this is saying is that your x value is negative b over 2a, and your y value is just taking this point that you found and plugging it back into your function. Obviously, both formulas are correct. This is just the one I'm going to be using in the examples. Okay. So looking at number 3, again, it's going to give us a problem in standard form, and we're going to have to answer the questions. So for part A, it's saying use the vertex formula to find the vertex. Okay, so we can't use the concept of changing it to the vertex form. We have to use that vertex formula. So again, rewriting that formula, we know that the vertex formula is negative b over 2a, and then f of negative b over 2a. So first we just find that negative b over 2a, and we're using that equation h of x. So negative b over 2a is equal to negative b, our b value is 2, which is already negative, so I'm going to write a positive 2, and then 2 times a. What's our a value in this problem? 1, so 2 times 1. So I have 2 over 2, which is 1. This 1 is our h value. Now I'm going to take that 1 and plug it in for x in my function. So I have h of 1 is equal to 1 squared minus 2 times 1 plus 5. This gives me 1 minus 2 plus 5, which gives me 4. And that 4 is my k value. So if I was to write my vertex, which is h comma k, my vertex is going to be what? 1 comma 4. Okay. Now it's asking us to find the x and y intercepts. So again, remember, in order to find our x-intercepts, we plug 0 in for y. And then in order to find our y-intercepts, we plug 0 in for x. Okay, so let's first do our x-intercepts. So we're plugging 0 for y, so that means instead of h of x, it's going to be 0. So we have 0 is equal to x squared minus 2x plus 5. Means we try the AC method, so we do a times c, which is 5. Our b value is negative 2. Can we find two numbers that multiply to 5 but add to negative 2? Yes or no? No, because what is our only multiple of 5? 1 times 5, and we can't make that -2, so this is not factorable, which means we use what? Quadratic formula. If you wanted, you could go straight to the quadratic formula. You don't have to factor, because the quadratic formula will work every time. So plugging everything in, I get x is equal to -b. Our b value is already negative, so I'm going to write a +2, plus or minus the square root of b squared, so -2 squared, minus 4 times a, which is 1, times c, which is 5, all over 2 times 1. Okay. From here, I simplify. -2 squared is 4, and -4 times 1 times 5 is -20. So that means I have 4 minus 20, which is -16, which tells me that my answers here are going to have what? Imaginary numbers. Okay. I know the square root of 16 though. What's that square root? 4. But since it's negative, it's going to be 4i. So I have x is equal to 2 plus or minus 4i over 2. Can I take a GCF of all these outside numbers? Good, I could take a 2 out. So that means I have x is equal to 1 plus or minus 2i. Okay, those are both my x-intercepts. Okay. However, since I have an imaginary number, these x-intercepts are not going to pass through the x-axis. So there's not going to be a way for me to plot these. Okay, so this is not going to be helpful when I graph because of these imaginary numbers. Okay. So because of that, I'm now looking at my y-intercept. And remember, in my y-intercept, I plug in 0 for x. So I have h of 0 is equal to 0 squared minus 2 times 0 plus 5. What happens to the first two terms? Cancel, so I am left with h of 0 equals 5, which means my y-intercept is what point? 0, 5. This is my y-intercept. Okay. Since I'm unable to graph my x-intercepts, what 2 points are the only points I'm graphing? Vertex and the y-intercept. So I know my vertex was 1, 4, and my y-intercept was 0, 5. Which direction is my graph going to be going, up or down? Remember, go back and look at my a value from the beginning. Is it positive or negative? Positive. Since my a value is positive, it's going to go up. And remember, my a value is this value here. Since it's a 1, it's positive. It means it's going to go up. Okay. And then the last thing I need to make sure that I am doing everything evenly is that axis of symmetry. And what was that equation? It didn't ask us for it, but we know how to find it. X equals h, and what was h? 1. So this is our axis of symmetry. Remember, it also goes right through the vertex. That's another way to remember. So if I was to graph this, it's going to look something like this. And again, notice how this graph does not go through the x-axis. That doesn't mean we don't have x-intercepts. That just means we have imaginary x-intercepts. Okay. Any questions on concept? I guess that was 2 and 3 combined, concept 2 or 3. Okay, this is the last concept, concept 4, where we're looking at applications. So looking at this example, we have that fireworks are launched at an angle of 60 degrees from the horizon. The height of one particular type of display is approximated by the function h of t is equal to negative 16t squared plus 128 times the square root of 3t, where h of t is in feet and t is in seconds. Okay. So question A says, how long will it take the fireworks to reach its maximum height? So before we determine how we're going to solve this, we're going to draw a diagram. Okay. So here is our graph. Here's our diagram. We're going to say that the x-axis is the ground. Okay. When you launch something, it's going to go up, and then eventually whatever is left of that is going to come down. Okay, so this is the start, this is the end. Okay. If it's saying how long will it take the fireworks to reach its max height, that max height right here is another name for what? The vertex. Okay. But if we look at that vertex formula, which is negative b over 2a, and then we plug that number into the function, negative b over 2a. What is this h value going to represent? Because remember, this first term is h in our vertex. Is it going to represent height or time? It's going to represent time. So remember, this is our h value, which is also our x-axis. And if we're looking at this, this is our time. Time starting here, ending here. That means the other value, that k value, is going to be measuring what? What's the other one besides time? Height. Okay. And what is the question asking for? It's asking us to find the max height. So even though we're finding the vertex, we're only going to include one part of that vertex, and that is going to be the k value. Okay, so let's go ahead and start solving that one out. So we do negative b over 2a. In this case, what is our a value and what is our b value? What is our a value and what is our b value? Good, this is our a value. And what's our b value? Good, so all of that besides the t. So that square root of 128 times the square root of 3 is our b. Do we have a c value? We don't, so c is equal to 0. Okay, so we're using those values to plug it in. So negative b means negative 128 square roots of 3 over 2 times a, which is 2 times negative 16. Okay. That is going to simplify to 128 square roots of 3 over 32, because those negatives will cancel each other out from top to bottom. And then since we are talking about a real world problem, we want a decimal answer. So you would plug this into your calculator, 128 times the square root of 3, all divided by 32, and you should get approximately 6.9. Okay. And since this is the h part of our problem, this is 6.9 seconds. So this is saying how long will it take to meet the maximum height? Okay. It will take about 6.9 seconds for the fireworks to meet maximum height. Okay. Remember, since it's an application, a word problem, our answer is always in a sentence. Then in part B, it wants that maximum height. So it wanted the time for the first one. How long would it take? So we used the first part of the vertex formula. And now in order to find the maximum height, what are we going to do with that 6.9? Good, plug it into the original equation. So remember, our original equation was h of t is equal to negative 16t squared plus 128 times the square root of 3t. Okay? So plugging in 6.9 for t, I have h of 6.9 is equal to negative 16 times 6.9 squared plus 128 times the square root of 3 times 6.9. You can plug this entire thing into your calculator and you will get approximately, so h of 6.9, approximately 768 feet. So the maximum height for the fireworks is 768 feet. And that's example 4. So that first one was an example of an application, so a real-world problem. This next and last problem, problem 5, is going to go over modeling. So what I mean by modeling is that in this question, you are not given the quadratic equation. Instead, you are given 3 points. And then using those 3 points, we're going to have to model a quadratic graph. Okay? Again, this is not tested this time. It's going to be tested on the final. So we know that the standard form of a quadratic equation is y is equal to ax squared plus bx plus c. Okay, because it says write an equation of a parabola. A parabola is the same as saying a quadratic equation, so that's how we know to start with that standard form. Okay. We're going to go ahead then and we are going to label each of these points. So this is going to be, since I have multiple colors, I'm going to do x and y. If you only have your pencil, do like x1, y1, x2, y2. Because we want to make sure we notice them differently. So this is x and y, and x and y. Again, if you're just using a pencil, make sure this is x1, y1, x2, y2, x3, y3. You want to make sure that these are all different x values. And what we're going to do is we're going to use these x and y values and we're going to try to find all our different a, b, and c values. So, for example, starting with the first one, our 1, -1, I'm going to plug in this x and y value into that standard equation. So I have y is equal to ax squared plus bx plus c. But instead of y, I'm going to put negative 1 equals a. Instead of x, I'm putting positive 1. 1 squared plus b times 1 plus c. So simplifying this, I have negative 1 equals 1 squared is 1. 1 times a is a. So a plus b times 1, which is b, plus c. Okay, this right here is my first equation. And I'm going to do that for the other 2 points. So now I'm going to do that for point negative 1, negative 5, which is my x and y value. I'm going to be doing the exact same thing and plugging in these values into the standard form for a quadratic equation. So I have negative 5 is equal to a times negative 1 squared plus b times negative 1 plus c. So I have negative 5 is equal to negative 1 squared is positive 1. Positive 1 times a is a. B times negative 1 is negative b, and then plus c. There's my second equation. Okay. Now I'm going to have my third equation using the point 2, 4, and I'm going to do the exact same thing as the first two. Again, this is called modeling a quadratic equation. So you're given information, and now you need to try to figure out what this equation could be. So plugging in 2 and 4, I have 4 is equal to a times 2 squared plus b times 2 plus c, which means 4 is equal to 4a plus 2b plus c. Okay. Okay, and then let's see, just remind me, did we do system of equations in here where we did substitution and elimination? The U substitution? Okay. Well, in order to solve for each the A, B, and C value, we're going to use something that is called elimination. So elimination is where we take these equations. So notice we have 3 equations that we found that are all in terms of A, B, and C. And we want to cancel one of the variables out by adding 2 equations together. So for example, if we were to add the equation in red to my equation in blue, what variable would cancel out? B. So that's what we're going to do. So this is now our fourth equation where we're using elimination to cancel B. Okay. So that means I'm going to take my equation in red, so negative 1 equals A plus B plus C, and I'm going to add it to my blue equation, negative 5 equals A minus B plus C. And I'm literally just adding these equations down. So I'm adding them down. So negative 1 plus negative 5 is negative 6. A plus A is 2A. My B's cancel, and C plus C is 2C. Okay. This is another equation that I found. Okay. So since I used the red equation and the blue equation to cancel out a B value, I am going to have to use 2 other equations to cancel out a B value again. Okay, so looking at my red, blue, and purple equation, which is the only one that has a negative B? The blue. So for sure I'm using that one. So I'm going to use elimination again to cancel out b. Okay, I'm using that blue equation because it has a negative b. So negative 5 is equal to a minus b plus c. Okay. And I already used the red equation with the blue equation. So that means I have to use what other equation? Purple, because I haven't used the purple one yet. So I have 4 is equal to 4a plus 2b plus c. But if I add these down, will the b's cancel? No. What would I have to multiply that blue equation by in order for my b's to cancel? By 2, and that's what I'm going to do. So I'm going to multiply this equation by 2. And so I have negative 10 is equal to 2a minus 2b plus 2c. And I'm just going to bring over that purple equation so it's lined up right underneath. And then I'm adding them down. Okay, so when I add them down, again, my b's are going to cancel. So I have negative 10 plus 4, which is negative 6. 2a plus 4a, which is 6a. My b's cancel, and I have 2c plus c, which is 3c. Okay. Okay. Any questions so far? So I just canceled out my b's. Now I have two equations, equation 4 and equation 5, where they are only in terms of what? A and c. So now I'm going to use that to form my 6th equation, and I'm going to use those equations. So negative 6 equals 2a plus 2c, and negative 6 equals 6a plus 3c. And I want to try to cancel out one of the variables. It doesn't matter which one. I can cancel out A or I can cancel out C. What would be the easiest to cancel out where I only would have to manipulate one equation? Good. And what could I get rid of from those two equations? The A's or the C's? The A's. So I would have to multiply that top equation by what? Negative 3. Okay. Which means I would have 18 is equal to negative 6a minus 6c, and then I bring over that other equation. So that means when I add these down, my A's are going to cancel. So I have 18 minus 6, which is 12, is equal to, these A's cancel out, and negative 6c plus 3c is negative 3c. Notice that the new equation that I got is only in terms of one variable, and that variable is c. Meaning I now know the value of c after I divide both sides by negative 3. I know that c is now equal to negative 4. Okay, so I found one part of my answer. Now I need to find A, and then I need to find B. Since I already know C, is there any equation up here that I could use to find another variable? So I already found C. So what equation could I use now to find another variable? There's two possible ones I could choose.
Like plugging C into one of the other equations we made?
Correct. So we could plug C into number 4 or into number 5. It doesn't matter. So I'm just going to go ahead and plug it into number 4. So I have... So remember, number 4 was negative 6 equals 2a plus 2c. But we know c now. We know c is negative 4. So negative 6 is equal to 2a plus 2 times negative 4, which means negative 6 is equal to 2a minus 8. We're just solving for a now. Add 8 to the other side. 2 is equal to 2a, which means a is equal to 1. So we found C and we found A. So in order to find B, what equation can we plug it into? To find B, we now have 3 options. What are our 3 options that we could plug it into? 1, 2, or 3, okay? It doesn't matter which one you plug it into, you're gonna get the correct answer. I'm gonna choose equation 1 because my B is already by itself and it's positive. So it's gonna be less work for me. So I have negative 1 is equal to A plus B plus C. So negative 1 is equal to A, I know A is 1, plus B, that's what I'm trying to find, and then C was negative 4. So solving for B, I have negative 1 is equal to B minus 3. Add 3 to both sides, I get B is equal to 2. So now that I found my A, B, and C value, am I able to now find what my answer is for the quadratic function? So remember, my quadratic function is y is equal to ax squared plus bx plus c. Now I have A, B, and C. So I can plug in A, B, and C, and I have my new parabola. So if I plug in A, B, and C, I have y is equal to x squared plus 2x minus 4. That is my complete answer. You're not going to be tested on this. This is just a modeling example, how if we're given some information, you're able to still find a parabola.